Hello, everyone. This is my Physics 2211, lab number 5, Choose Your Own Adventure. So, as an introduction, um, what I did for my lab was I took the video from lab 2, the code, and I improved it, right? The purpose of the lab was to improve on a previously done experiment. So, we explored projectile motion, but we also added energy graphs to the analysis of it. So this would allow us to explore the energy principle in different scenarios because we've done that with, kind of like the spring experiment. And this helps us build on previously learned fundamental physics principles. Speaking of, let's talk about the fundamental physics principles here. The work energy principle states that the change in energy is equal to work done by the surroundings. Um, in this case, I think the change in kinetic energy plus the change in gravitational potential energy, you see the equation there. We also use Newton's second law for the velocity update and position update formula, but you can see the equation there for that as well. But also, I want to talk a little bit about conservative and non-conservative forces. Um, Drag force from air resistance is a non-conservative force, and you'll see that come into play later on in the results, where the energy of total energy of the change in energy of the system was not zero. But let's talk about the observational model. So the system in this experiment was the wadded up paper ball, and the surroundings include everything around it. So gravity from Earth would be potential energy, potential gravitational energy. And then, like I said earlier, drag force from the air is a non-conservative force. So something like this would allow us to have not have work done on the system from surroundings, which would help simplify the calculations. And excuse me, more on the observational model you see here, tracker, the images in tracker. Um, yeah, I mean, that's it. That's the tracker stuff. Okay, talking about the computational model, it's a program in GlowScript. I converted the tracker data to a CSV, just like in Lab 4. Um, but the ball's initial velocity and position was calculated from tracker data. Position was taken from tracker. The velocity was calculated from the first few frames. You see the code there with the initial conditions. And then this shows the code that I had to kind of put together. I took code from Lab 4 and from Lab 2 together. So I did define the initial energies, calculate the net force, but then also um, calculate the energy changes and the moment after the momentum principle. And when graphing it, you'll see that x position versus time, y position versus time, that matches the same from Lab 2. The observers is predicted from Lab 2. I put that in there as well. But the thing that's different is the change in energy versus time. You'll see that the delta U spring is still not, couldn't figure out how to get that. But delta E, the orange line, it's not constant because of the non-conservative force of the drag force acting on the ball. So it does go in the negative direction. I mean, it goes up a little bit because I assume the initial velocity wasn't calculated very correctly, but I'll touch more on that in the errors section. But basically, this is the overview of the results here, and you'll see that modeling projectile motion. I mean, the video ended before the object landed, came to a full stop. So the kinetic energy, there'd still be kinetic energy at the uh, very end of the video or the analysis as well. Now, moving on to some what does it mean for a model system? I took the original question about this, is the energy principle satisfied? And I said yes, it is satisfied because of the drag force acting on the ball. We said that considering the system to be everything, but the drag force is a non-conservative force, and so I guess you could assume it be. I guess you could also put it as work done on the system from the surroundings. It really depends on your interpretation of the system. So there's that. And then errors, there's human error in tracker while tracking the object, but I think the biggest source of error in this case would be from the computational calculation code because I haven't done Python coding in like 3 years. So I don't know if I did it right, and also GlowScript is weird. But and also any other work done in the experimental system that was unaccounted for, that's not like gravity or drag force. Thank you very much.